Yeah, I just, okay, here comes the recording. So she's just started the recording for us. So welcome everybody. My name is Bill DeVincenzi. I am a former lecturer from the College of Business, and my colleague next to me is Ken Wharton. Ken, would you like to tell people a few words about yourself?
Hi, everyone. I am a professor in the physics department at San Jose State, and been there almost 20 years, and but just recently have started getting active about climate change and starting to be trained to give talks. And I'm the backup today, but I will be looking at the questions in the chat and organizing them as the talk goes on.
Great, thanks, Ken. And Debbie Andrews. Debbie, did you want to introduce yourself and talk about the chat and what people can do there?
Hi, I'm Debbie Andrews from the Office of Sustainability, the only staff member at the Office of Sustainability right now. Thank you for coming to this, one of our internal events for Campus Sustainability Month. So thank you everybody for keeping up to date with our events and coming to this. Again, yes, please send your chats in the window. Oh my God, please send your questions in the chat. And Ken will either answer in the chat or ask at the end. Thank you.
Okay, thank you, Debbie. And I'm going to begin to share my screen with you so we can get started with the presentation. Okay, so just a little bit about myself. My background is corporate finance, where I spent my first 28 years working in the executive level as a CFO for the last 10 years. I retired, or thought I did, and then I just absolutely fell in love with teaching. I was offered to teach one course, and then it was two, and then it was full-time. And I've been a full-time lecturer for almost 25 years in the College of Business. I retired again, and one of the things I learned is I'm very, very poor about retiring. And so I tried to figure out, well, what else could I do with the rest of my life? And the subject of climate change came up, and I said, yes, that's something that I can get really passionate about. And so I joined Elders Climate Action. It was a group of people that I knew. And then I got introduced to the Climate Reality Project. And so in August of 2018, I was trained by Al Gore to give climate reality presentations like this one. I then joined the Santa Clara County chapter. I'm co-chair of their Speakers Bureau, which is why I'm here today, but also because as a 25-year career instructor here at San Jose State, I think it's extremely important that we bring climate reality here to campus. I also founded a Sustainable Villages. That's the place where I live, the Villages in San Jose, and it's another one of my life passions. Okay, so let's get this moving. So the ground rules, pretty straightforward. This is bipartisan. There are no political affiliations. I've always considered this to be a moral and humanitarian issue, but somehow this got co-opted into being a political issue, kind of like COVID. It's kind of hard to believe how these things can become political issues, but unfortunately they have. I've done my own research. I've also rely on a lot of the research that the Climate Reality Project has done. I have vetted my sources on all my slides, and so I'm very comfortable with what you're going to see and hear. And the reason why I'm doing this is pretty basic. I'm concerned about the future that I'm leaving for my children, my grandchildren, all my former students who I've trained to become successes in the business world. Well, I just hope that there's a good world for them to be a success in. And so that's why I'm doing this. So my talk today is broken down into three parts. Must we change? Can we change? And will we change? And the first part about must we change is climate change real? I mean, there's a lot of deniers out there, right? People who even think this is a hoax. And is it really a problem? So that's the question that we'll deal with right now. So I start with the biggest picture. This is, of course, that famous picture of the blue marble that was taken by Apollo 17. They were heading to the moon, and they looked back and they saw this incredible sight. Okay, our planet just kind of out there floating in space, and it's like, oh my God, it's one of those unbelievable moments where all life, everything you know and love, is sitting right on that little ball that's floating around out in space. And it was a religious experience for a lot of them. What I wanted to focus on right up here, you can see it looks like a little membrane, a little blue membrane. And when we blow that up, that's our atmosphere. So this atmosphere is roughly about 5 miles thick. And you think, well, that's pretty thick. Well, not when you consider that it surrounds a ball that's 25,000 miles in circumference. And you say, oh, okay, that's actually razor thin. And the problem is that atmosphere is being polluted by industrial pollution right now. And so let's talk about how that impacts the heat of the planet, or global warming. So the sun provides radiation to us in the form of light waves, and basically 3 types of light waves: the visible light, which makes us be able to see in the daytime; ultraviolet, which if you're not careful can give you sunburn; and infrared, which is what actually heats the planet. Most of this radiation is absorbed by the Earth, either land or ocean, and warms it. But some of that energy is radiated back into space. It kind of reflects off the ice and off the land, and so some of that heat is lost. And that's actually a good thing, because otherwise we might be roasting. However, some of that heat, some of that infrared, is trapped by the atmosphere, and as the greenhouse gases that exist there. And what this has done over the millennia is to form a nice, consistent temperature range for the planet. However, right now, as I mentioned, we're spewing 152 million tons of man-made global warming pollution into this really thin shell of an atmosphere every 24 hours. And so what that's done is it thickened that blue. Now you see that blue membrane here has just gotten a little thicker, and more of that infrared is being trapped. And so it's like a blanket, right? And so hence global warming. And the thicker that atmosphere gets, the more global warming we're going to experience. So just a little definition of terms here, because we see global warming, we see climate change, and they're kind of used together sometimes, but global warming is the cause. Climate change is the effect of global warming. And climate change can be either hotter or colder, okay? So, and we'll talk about how that works in a little bit. And of course, the result that we're experiencing right now is called the climate crisis. The largest source of global warming is the burning of fossil fuels. And you can see this demonstrated very clearly in this chart, because it starts right about the advent of the Industrial Revolution. And this is just simply man's contribution to the CO2 in the atmosphere. And you can see that that's gone up alarmingly steep. And you say, okay, well, so where does that come from? And you can see from coal mining to coal plants, where that coal is burned, to crop burning, oil production, fertilization, land transportation, air transportation, landfills, agriculture, of course, cattle, and industrial processes. These are all, adding to this greenhouse gas effect that we're seeing on the planet right now. So to demonstrate, I have 2 charts here, which I think are really interesting. This one shows 800,000 years, and it shows the level of carbon dioxide in the atmosphere over that period of time. And so you notice it's roughly between 200 and 300 parts per million until you get to the Industrial Revolution era right here. And then all of a sudden you see this thing just spike straight up. Okay, and this is definitely caused by humans. In fact, if we take this to today, we're roughly at 417 parts per million, so we're still going up. And that's not a good thing. Now, the way they did this, it's really interesting, is that they took ice core samples in Antarctica, and those ice core samples contain gas, and they're able to take a look at that air and determine what the level of carbon dioxide is. So they were able to go back 800,000 years, pretty accurate measurement. On the other side, in terms of the heat of the planet, samples were taken from the ocean floor because they're able to date based on, they can calculate the heat of the planet based on the, interesting enough, looking at clamshells, and clamshells grow faster when it's hot and slower. And they're able to actually measure, and they go back millions of years in terms of measuring the heat of the planet. Then they compared the two and came out to this astounding conclusion. Two totally separate scientific approaches came up with, so you got CO2 on the top and the heat of the planet on the bottom. And it's like, oh my God, this is like exactly cause and effect, right? I mean, look at every time CO2 goes up, heat goes up, goes down, heat goes down. And that tracks all the way to the present day. And so now we're looking at, CO2 levels at, 417 parts per million. And the red line, or the temperature, has not reacted yet, thank God. And the difference is, you can see between these two, there's a time differential, okay? And whether that's 100 years or a couple hundred years, I'm not sure. But we have time. How much? We don't know. But you can see that this is already starting to spike up. And if that temperature of the planet tracks as it has done in the past, life as we know it will be extremely different and may not include human beings in the future. So this is why we need to act. This one slide worries me the most about anything I'll be showing you. So have we seen any evidence of this yet? Well, glad you asked. Oh, by the way, that data is demonstrated in this documentary by NOVA, Decoding the Weather Machine. And it talks about how both of those slides were created. It's really fascinating, but just remember NOVA season 45, episode 6, Decoding the Weather Machine. Have we noticed any change? Yeah, 19 of the 20 hottest years on record have occurred since 2001. And if that's not bad enough, the hottest of all have been the last 5 years in a row. And where's 2020 fit into this? It's going to be somewhere between 2016 and 2019. It's either going to be the hottest year or the second hottest year ever. So yes, there is evidence that that red line is starting to move up and track the CO2. And again, another reason why we need to do something soon. So where does all this heat go? Some of it goes into the ocean and some goes into the land. I'll talk about each one of those. So you can see that the ocean temperature starting around 1975 has just, been on this track and this meeting a midpoint here. But you can see that this is starting, had started to heat up quite a while back and has heated up continuously since. And the impact on the ocean is pretty significant. First of all, hurricanes. Warmer oceans lead to more intense hurricanes because cold water typically will short circuit a hurricane and cause it to slow down. Warm water just kind of feeds it. And it allows hurricanes to intensify much more rapidly. I'll give you an example of that in just a minute. And warm air holds more moisture because of evaporation. So you get more moisture in that hurricane and more downpours. In fact, 1 degree Celsius will give you 7% more water vapor. I'm going to use that in just a minute. And then, of course, storm surges go further inland because of sea level rise. And storms tend to stay in place longer and precipitate for longer levels of time. And the perfect example of this is Hurricane Harvey, which hit in 2017. It crossed the Gulf of Mexico in waters that were up to 4 degrees Celsius warmer. Now, remember I said 1 degree Celsius equals 7% more precipitation. So we're talking 28% more moisture in that particular hurricane that slammed into Texas and Louisiana. And here's the result. Over 50 to 60 inches of rain fell on Texas, parts of Texas and Louisiana over a period of 5 days. So that storm sat there for 5 days and this is the equivalent of 500 days of Niagara Falls. If you've ever been there and you've seen the humongous amount of water pouring over those falls, that's what hit these guys back in 2017. Speaking of hurricanes, in the news over the last couple of weeks, Hurricane Delta hit Texas and Louisiana, same area, and it followed Hurricane Laura that hit the same area at the end of August. Delta is interesting because it's the 25th named storm in this year. Normally there's about 12 in a hurricane season. We only use 21 letters of the alphabet. So after we've used up 21, we go to Greek, hence the name Delta, okay? This hurricane intensified to a category 4 in 3 hours. I said something about, the hurricanes intensifying more rapidly. This was a record. It's the 10th named storm to hit the US soil, which is the most in any one year, and the 5th hurricane to hit. So, and we're only halfway through the hurricane season. So there's more to come. Let's talk about the land now. Global surface temperatures follows pretty much the same pattern that you saw with the ocean, with the increase in global temperatures, starting in the 1940s, really, and continuing on up through the present day. So what is the impact there? Well, for one thing, we don't have to go too far since we live here in California to know that fires have intensified, and you can see that there's a direct relationship again between the temperatures and the number of large fires. And so you can see that going all the way to 2018 now. Too bad, because in 2020, we're gonna have to redraw this chart, right? With all the fires that we've had. You remember the Camp Fire that destroyed Paradise, California, a couple of years ago, almost to the day. 86 people died, a terrible loss. How about 2020? So we thought that was a bad year. The August complex fire is the largest ever, a gigafire. Over 1 million acres have burned. Now it's 92% contained, so it's probably not going to go much over that, but it dwarfs the Mendocino complex fire of 2018, which was 410,000 acres, which we thought was huge at the time. But look at the rest of this. The third largest ever fire was this year here in Santa Clara County. The fourth largest up in Napa happened this year. The fifth largest is still burning east of Fresno, and it's only 61% contained. That's the Creek Fire. And then the sixth was the North Complex Fire, which is now 95% contained. But notice that, and of course you've been reading about the one in Napa, and finally that one's pretty much contained, so thank God there. But this is all happening this year. Year to date, over 4 million acres have burned. The previous record was 2018, which we thought was really bad, but that was 1.7 million acres. So we've already burned over double that amount, and the fire season is not over yet. Worldwide, it's not just here in California, worldwide weather catastrophes have been consistently on the rise, as you can see from this particular chart. Now, can global warming cause extreme cold? You say, well, how does that work? Well, actually it can. In February of 2018, as an example, the temperature at the North Pole was 50 degrees higher than normal. And what happened was that there were some extremely hot weather conditions in Asia that moved north, okay, and impacted with the cold air up in the North Pole. Now, the polar vortex is basically a mass of cold air that kind of circles around the pole. And normally when it behaves itself, it just stays there and keeps that area nice and cold. This warm weather punched into that vortex and caused that cold air to split. And what it did was it sent cold air down into the northern part of the US and into Europe. And you can see the graphic here about how that happened, and watch from Asia, you'll see that hot air move up there and cause that polar vortex to split. So the impact in Chicago during that same period, the boardwalk along Lake Michigan totally froze over. Temperatures dropped to -22 degrees. And my niece, who lives just outside of Chicago, said they couldn't go outside for 3 days because it hurt their lungs to breathe. I mean, that's bad. And on the other side of the planet, in England, Trafalgar Square froze over. There was snow and ice around the Colosseum in Rome. So yes, global warming can cause extreme cold conditions as well. Sea level rise. So this chart basically shows those cities that are most at risk in terms of assets. So, destruction of facilities. And Miami and New York are two of the top three because they're very low level. In fact, right now, Miami Beach, there is flooding right now today in the streets in Miami Beach. when they have high tides. It's just normal, unfortunately. What about the Bay Area? Well, if we have a 20-foot increase, which is possible, not probable, but it's possible by the end of this century, and that depends on what happens in Greenland and the Antarctic ice shelf. But if we were to see that happen, San Francisco and Oakland airports would be underwater, and a significant part of Hayward, Fremont, and down the peninsula, Alviso would be totally underwater. So we have significant risk here in the Bay Area for sea level rise as well. Now, I might not see it, but you might see it, and your kids would certainly see it. So something to think about. Food. So climate change does affect food because it can cause droughts, can heat, which can cause nutrition to bleed out, cause yields to be lower. You would see more toxins and of course more fires. So food is definitely impacted by climate change. Water as well, because if you remember all that water that fell on Houston, that all ran off into the ocean. It didn't really have time to sink into the ground when it happens so quickly. So you see melting ice and runoff causing sea level to rise. And then on the other side, you'll see other areas that have drought. So the supply of usable water has been depleted, and yet the demand has increased, especially in the area of agriculture. Your health, okay, another negative impact here, because extreme weather events can cause more infectious disease, can cause more air pollution. We said less water and less food, more allergens, more heat stress. So health is also negatively impacted, and you can see these are all interconnected. Worldwide, and here's a statistic that just blew me away. Worldwide, air pollution kills 9 million people every year. We don't see it in this country so much, but in third world countries and in China and India, that's where it's hit the hardest. In fact, Bay Area, just let's get right down to it here. There's been 51 Spare of the Year days here in 2020. That's a new record. The previous record was 46 back in 2017. And we still have a lot of the fire season left. So air quality here, even with, you think, oh, gee, with COVID and the reduced amount of driving and things we do, but here we are because of the fires. Species extinctions, we now risk losing up to 50% of all land-based species in this century. This is being called by a lot of scientists the largest mass extinction since the extinction of the dinosaurs 65 million years ago. When it gets too hot, we can always turn on our air conditioning or have less clothes. These guys can't. And so when it gets too hot, they die. Now, the cost of carbon is not just what it costs for you to dig it out of the ground, because we're seeing that as we burn carbon and throw more CO2 up into the air, we have more wildfires, we have more drought, we have more storm damage, ocean acidification, which has killed off 50% of the coral on the Great Barrier Reef, climate refugees, species extinction. All of these things are part of the cost of the economic cost of carbon. And so this is something that people don't really take into consideration, but the World Economic Forum says this is the #1 threat to our global economy. Have there been serious scientific studies done in this area? Yeah, quite a few. The Intergovernmental Panel on Climate Change does a report every 6 years about climate change. And this time their report focused on a 1.5 degrees Celsius increase, which is what people signed up to in the Paris Accord, versus a 2.0 increase. Now, this is since Industrial Revolution 1880 forward. And their conclusions were pretty dire. So if you think about all I've just shown you, climate change impacts, fires, floods, et cetera, this is all as a result of a 1.0 degree increase since the Industrial Revolution, Celsius. So the implications of a 1.5 degree or a 2.0 degree impact would be significantly worse. So just think about what we're experiencing now getting that much worse. And the time frame that they had originally thought was about 2050 has now been brought forward to 2030. And 2030 is less than 10 years from now. So it becomes even more urgent now to take action immediately. We cannot let the government drag their feet any longer. Now, the US National Climate Center, we do our own climate assessment in the United States. The fourth one was completed in November of 2018. And it acknowledged, one, that global warming is real, and two, that human activity is the dominant driver of global warming. Where is our administration in this all? In all of this, they're denying that global warming even exists, and yet our own US National Climate Report says differently. Now, why didn't we find out about this? Well, because the report was released on Black Friday. Now, why do you think they did that? Because no one's looking at the news, they're looking at the ads, right? So deliberate cover up. Again, we cannot let this slow us down. We need to take action and make change happen. Now, we're in the middle of a pandemic. And so I thought there were some parallels that we might look at from pandemic and coronavirus. So the pandemic is short-term typically, and now I may have to change this slide since it's going on and maybe even getting stronger. Climate crisis, however, is over many, many, many more years, okay? It's slow, gradual, and just continues. Pandemic cases tend to accelerate pretty quickly, which they have. Now, typically, they might peak and flatten out and maybe even go down, but it doesn't look like this one's going to do that. The climate crisis accelerates slowly, but never flattens out and just keeps getting worse. And when the Arctic melts, it's gone, folks. And when the sea level rise happens, you know, there's like 1 billion people that are living right around the edge of the oceans. The mass migration from that will be permanent. Where are all those people going to go? Okay, wetter wets, hotter hots, drier dries forever. And I'll have to give credit to most of that from Thomas Friedman, who's a renowned reporter for the New York Times. Have we learned anything from the pandemic? Well, first of all, we need to act. Inaction in this country has cost a lot of lives. I mean, 220,000 people have died from the pandemic here in the United States alone. So we need to do something. We need, as far as climate change is concerned, we need to shift to renewable energy now. We need to decarbonize power generation now. We need to incentivize cars and buildings and workplaces to become carbon free now. And we have to be just as focused on these as we are on the things we're doing to try to reduce the impact of the pandemic. You know, our shelter in place, our wearing masks, our social distancing, et cetera. What must we not do is go back to business as usual, because that wasn't working. I mean, we did notice lower emissions and cleaner air during the March, April, May timeframe. And that was a relief until the fires messed things up. But remember one thing, very important. Unlike the pandemic, there will never be a vaccine for climate change. So the last slide in this segment, and then we'll get to hopefully some better news. When we talk about 1.5 degrees Celsius, 2.0 degrees Celsius, that doesn't sound like much. It's like, you know, okay, so it's a couple degrees hotter, you know, big deal. Actually, it's a big deal, because if you look at this chart, and it says that if the temperature Fahrenheit is slightly less than 32 degrees, you got ice. If it's slightly more than 32 degrees, you got water. And this is called a tipping point. And what's happening is that tipping point is moving north, okay, and south towards the South Pole. And as that tipping point continues to move north, more and more ice becomes water. And that's exactly what's happening. So it doesn't take much of a change to make a drastic impact. So is climate change real? Yes. Must we change? I hope I maybe convince you that we absolutely must. So if we have to change, can we? Okay, well, there's good news here because we do have the solutions at hand, and it's called clean renewable energy. If we look at wind, for instance, we'll notice that in the last 10 to 20 years, the amount of megawatts in terms of wind capacity has increased dramatically. Now, this is just a small piece of what the total energy requirements are, but the movement is in the right direction. And how are we able to do that? Well, look at the costs. As a finance guy, I like to track how this works and see costs have dropped dramatically, per megawatt of cost for wind, and that's why you're able to see a lot more wind going up. So this has to happen. It's not going to happen because of altruistic reasons. There's going to have to be a cost benefit. Globally, wind can supply worldwide energy consumption 40 times over. So there's a lot of wind, more than enough. All we need to do is build more turbines. How about solar? Well, solar is even more impressive. You look in the last 10 years, the installation of photovoltaic cells has increased dramatically and continues to increase. And how did this happen? Well, I like this chart the best. We started at almost $80 a watt for crystalline solar cell modules, and we're down to like under 25 cents now. So it's kind of like Gordon Moore's, what I want to say, a formula for cost reductions in chips. So the cost has gone down substantially. Now you say, well, why haven't we seen it in the marketplace? Well, global energy subsidies play a huge role. Now you see here that renewables are subsidized 143 billion. You say, oh, wow, that's a lot. Well, compare it to fossil fuels, 5.3 trillion, or 37 times as much. Renewables, yeah, they should be subsidized because it's a new technology. The fossil fuel industry is dying, and the only reason it's not dead yet is because of this. So, we need to take a look when we have an opportunity to cast our votes and put an end to a lot of these global energy subsidies and bring a level playing field. Now, speaking of a level playing field, if you took those subsidies away, here's what the costs look like. You can see nuclear is the most expensive because those plants are extremely expensive to build. Conventional coal, earning about $100 per megawatt, gas around 60, and you're going to see gas is replacing coal. Why? Because it's cheaper. Okay, so again, the cost effect. But look at renewable, look at solar and wind. They are both cheaper than gas right now, today. So this is the direction that we need to go in, and it's there already for us for the taking. There's enough solar energy that hits the earth every hour to fulfill all of our energy needs for a full year. So prodigious amount of energy that comes from the sun. So the question that always comes up is, well, what happens if the sun don't shine and the wind don't blow? Well, you need storage capacity, right? So we can see here a projection on what storage capacity is projected to do. This is Bloomberg, which is a very good source, and they're projecting a significantly huge increase in storage capacity. You say, well, how is that going to happen? Well, first of all, look at the cost of lithium-ion batteries over the 8 years. The cost is go down 80%. Wow. Okay. And I predict that that's going to continue to go down. There's a lot of investment being put into stronger batteries. You can see Tesla and other companies working on this, and for and lower cost. Look at the investment money, and it'll make this even more believable. Right now, twice as much money is going into renewables as into fossil fuels. And by 2025, that's going to be like over 3 times as much. And by 2030, it's projected to be almost 5 times as much. So investment money is going into clean energy, and fossil fuels, that you can see, is actually going down. And at this point, I'll turn this back over to my colleague, Ken Wharton, who has something to say about what's going on right now.
Thank you, Bill, and thanks for the talk so far. So I did just want to mention that despite all of this great movement in the right direction, and building on that movement, every country in the world submitted a plan to the Paris Climate Accord as to how they could build on all of this increase in wind and solar and reduce the carbon output, and put out very ambitious national plans that, as you can see here, are going to reduce the amount of carbon emitted to the blue line from the red line, the kind of reference scenario, where this is the vertical here on this graph is the gigatons of carbon dioxide equivalent per year. So methane is worked in there as well. Now, a couple of things about this, and Bill will probably say more about the Paris Climate Accord later. But first of all, at business as usual, the kind of guess of where we're going to end up here in 80 years is a 4-degree warming. So right now we've had 1 degree of warming. We're aiming for 4 degrees of warming, and it just gets worse from there. If all of the commitments at Paris are implemented, we could maybe reduce that to 3 degrees of warming. And we are not, basically very, very few countries in the world are actually meeting the plan. So even though we have plans to do it, and even though things are seeming to move in the right direction, we are not meeting these benchmarks that all of these countries have put out. And in fact, the Trump administration is about to remove ourselves from the Paris Climate Accord in a few weeks. Depending on what happens after that, we'll have to see. If we want to keep down to 2 degrees of warming, Bill, maybe you could advance this here. There's this arrow point. Oh no, here, maybe it didn't show up. You back up for 1 second here. So there's an arrow pointing to the 2-degree path. And if you see where we need to be in 30 years, we need to not only stop the growth of emissions that are now basically on track for, but we need to cut it to about half. And that's just to get to 2 degrees, which is really, really bad. That's like one of the really bad outcomes compared to 1.5. What people would love to do is get to that light green curve and actually stop emissions by 2050 and 2060 altogether, and maybe even have some negative emissions. Maybe then you could keep it to 1.5 degrees, which are still really bad outcomes. 2 degrees is exponentially bad beyond that. 3 degrees would be exponentially bad over that. And 4, it's many parts of the planet just simply become unlivable with 1 billion climate refugees. It's really hard to imagine where we're headed if we cannot do better than what we pledged to do. And on that line, the next view graph here points out that all of this discussion of electricity production is only 25% of the problem. You can see this is the source of all the current worldwide greenhouse gases. And suppose we completely phase out all of carbon fossil fuels, that's 25% of the problem. If we go to all electric cars and all and transportation includes airplanes and boats, that's another 15% of the problem. Even if we did all that, it's not nearly enough, certainly not to get down to half of what we're emitting. We have all sorts of other aspects of our economy. Every aspect of our economy is going to have to be addressed. Now, there are plans to do this. I mean, one of the more detailed plans is the source of this slide, Project Drawdown, is definitely worth checking out online. They have a list of, we do this big project, this big project, this big project. They have 100 big projects. Each one chips away at the problem. And if we do them all, we can barely get a handle on this. But if somebody tells you, oh, this is the solution, it'll save a megaton of carbon, that is one of many, many solutions we all need to implement to really have any hope of a livable planet. So I just wanted to talk about the scale of the problem a bit here.
All right, thanks,
Okay,
Ken.
thank you, Bill.
No, I appreciate it. And just I just heard on a documentary that I'll be talking about in a minute that this anything we do today, maybe it doesn't solve the problem 100%, but it's going to make life better at some point in the future, whatever we do today. So maybe we won't see it in our lifetimes or the next lifetime, but it will be better for somebody else in the future. So we need to take action no matter what. I mean, look at auto manufacturers. If I showed you this chart 10 years ago, there'd be like maybe 5 or 6 names on it, producers of electric cars. Now, all major car manufacturers are producing electric cars, and that's good news. They see the future here. Now, here's something that could be a real change maker. If you look at the powertrain cost, the engine and what have you, of efficient fossil fuel powered cars, this is the projected increase in cost over the next 15 years. Here's what the projected mainstream battery electric car cost is for their powertrains. And you'll see that in just a couple years, the powertrain cost on electric cars is going to be below the cost of fossil fuel cars. When this happens, and when electric cars become cheaper than fossil fuel powered cars, you're going to see a dramatic shift in the number of electric cars on the road. So this is very promising. And my last slide in this segment is my favorite slide of all. This is the Kentucky Coal Mining Museum in Benham, Kentucky, and they have just installed solar panels on their roof, and they estimate that they will save $8,000 to $10,000 a year in energy costs. You got to love the irony of this one, right? Coal mining museum, solar panels on their roof. If they can make that kind of a change in their philosophy, hey, so can we. So can we change? Yes, I think we can. The technology is there. And now the question is, will we? Okay, so let's talk about that. So as Ken mentioned earlier, you know, the Paris Accord was signed in 2015. Every nation in the world agreed to come together and work towards net zero greenhouse emissions by mid-century, meaning 2050. The only good news about the administration's desire to withdraw is they cannot legally do so until the day after the election. Now, it has nothing to, it's just a coincidence it's that day, but it would be the day after the 2020 presidential election. Now, even if we get a new administration in office, they don't take over until January. So I would imagine that the current administration is still going to kick us out. But the good news is we can get right back in again. The important thing is that we want an administration in there that's going to keep us working in the Paris Agreement, because all the other countries in the world look at us for leadership. And if we pull out, this whole thing is going to collapse, folks. We cannot let that happen. We have a great accord going, and you know, whether people are meeting their commitments or not, you know, China and India are working towards it. I don't know, you know, they're on track, but you know, whether they actually achieve their goals or not, as Ken says, we don't know. But China and India, China does pollute more than we do in total, but on a per person basis, we pollute way more than anybody else. So we need to take stock of that as well. But let's take a look at China and India, okay? Since they are being designated as the big polluters. But look at new energy capacity in China. In 2018, 53% of their new capacity came from solar and wind. Now, admittedly, China is the biggest user of burning dirty coal, right? But that number is going down. China is also the largest manufacturer of solar cells. So guess what? You know, I just look at this and I have a very positive feeling, because that's why they're going to do it the same way we would do it. If there's a cost benefit, they're going to go to solar and wind. And I think they're the ones who can really make this happen. My second favorite slide is this one. This is a solar farm in China. The Chinese government, I don't think, has ever been noted for having a sense of humor, but you got to love this one. It's only visible from the air. And, you know, I think, you know, they deserve some credit for this. What about India? India is even better. 65% of their new capacity was from solar and wind. And again, they're also a huge user of coal. But again, as wind and solar continue to dominate their new capacity, that reliance on coal is going to become smaller and smaller. So another positive trend. Europe is winning the battle gangbusters. 88% of their new electric capacity is from wind and solar. So they are doing the yeoman's job of making this happen. How about the US? Well, we're not too bad. You know, 49% of new capacity is solar and wind. The other, basically 50%, is natural gas. And what's happened to coal? Non-existent. As I mentioned, the cost factor enters in here. Coal has been almost entirely replaced now by natural gas, as well as by solar and wind. So that's very good news. But remember, gas still burns dirty. And so we need to start making inroads on natural gas now. So not surprisingly, the US consumption of coal has been dropping like a rock and will continue to do so. And why? Because there are no new coal-fired plants coming into existence. In fact, they're being replaced. Last year, for the first time ever, there was more energy consumed from renewables than from fossil fuel. Okay, That's the first time since measurement started. Fossil fuel investments, interestingly enough, declined 40% in value so far this year. Renewable energy, on the other hand, went up 2%. Now, this is in a down economy. So what that's telling you is that smart investors are pulling out of fossil fuel and moving into renewable energy. By 2020, the US is expected to retire an additional 13 gigawatts of coal-fired generating capacity. So they're shutting down coal-fired plants. And at the same time, they're going to add an additional 186 gigawatts of solar and wind. So awesome. We're making that shift even more dramatic in the US. Jobs, what about jobs? The two fastest growing occupations in the United States are solar panel installers and wind turbine technicians. And this is from the US Bureau of Labor Statistics, okay? So we are creating more and more jobs with this conversion to renewable energy. Over 190 global companies have a commitment to go to 100% renewable, and that's by mid-century. And so that's a quick look-see. I'm not going to leave this up there, but 190 companies are going in that direction. You see Walmart and Google and others on there. Also importantly, 20 states, and I think that's up to 23 now, representing over half of the American people, have formed the United States Climate Alliance. And what this does is it says, hey, whether we pull out of the Paris Accords or not, these states are saying we're going to stick with it and we're going to operate in accordance with the climate agreement. So that's huge news. So regardless of what the federal government does, they're going to stick with it. And in fact, in California, in 2018, as Jerry Brown was leaving office, he passed legislation requiring that by 2045, 100% of the state's electricity is going to be carbon free. Now, California is like the fifth, looking at it by itself, is the world's fifth largest economy. So California by itself can have a huge, gigantic effect on all this. What about big money? Something I'm personally interested in. Now, BlackRock is the world's largest investment manager. They have over $6 trillion in assets under their management. And they issued a climate risk warning to their investors. Okay, and they're basically saying that, hey, look, the market is under pricing the climate risk, meaning your investments are overvalued. But what's most important about this is the fact that BlackRock, now they have their own things to worry about, but BlackRock is recognizing the reality of climate change by offering this kind of advice to their investors, and that's big. That it's being recognized by big money. In fact, the Federal Reserve, is looking at the impact of climate change risk on long-term monetary policy, and they're saying that from now on, the risk associated with climate change is going to be a major factor in deciding whether or not they're going to raise long-term interest rates. Again, this is huge. Because they think climate change is going to have a significant impact on economic growth. So here you're having big money, the federal government, financial part of it saying, hey, this is real and we need to take it into consideration. Okay, final segment, what can you do? So these two are pretty obvious. Putting my money where my mouth is, I installed solar panels on my roof. My anniversary is coming up in late November. So we have solar panels up there that are cranking away way more energy than what I need. In fact, my electric bill has gone from $125 a month down to 10. And I will be paying this off in less than 10 years based on my savings in electricity. I also bought my electric car now a little over a year ago. And again, reaping the benefits of that. I'm in essence driving it for free because I'm generating my own power to make that happen. Now, if you don't have the money to buy an electric car, although they're getting cheaper, and if you don't have the money to put up solar panels, everybody, college students as well, can do this one, and that's up to 100% renewable energy. So anyone who lives in the Bay Area, and in San Jose, city of San Jose, San Jose Clean Energy is our community choice energy association. Basically what these guys do is they buy energy from energy producers, clean energy producers, and provide it to you. So right now, as an example for Silicon Valley Clean Energy, they're buying the energy, and anybody who is in this district, 50% of what they're getting right now is clean, but 50% is still fossil fuel. You can opt up to 100%, and meaning they have to buy enough clean energy to provide you with 100% clean energy. And for what looks to be $3.60 a month more, you can have 100% clean energy delivered to your door. $3.60. Come on, guys, that's like a latte a month. I think we could afford that. In fact, I've been tracking my own. I did this well over a year ago. I'm about a year and a half now into this, and my average cost is less than $2 a month. So, and of course, you know, it's going to go the other way as green energy becomes less and less expensive. So this is something we can all do. Talk to your friends, your family, and anybody who lives in the Bay Area to opt up to 100%. I think that would be a great thing. What else can you do? Vote. We got this huge election coming up in a couple of weeks. And so vote pro-climate, you know, whether it's laws, whether it's candidates, vote pro-climate, encourage everybody else you can to join you in this. There's a couple of great documentaries. One is called Ice on Fire by Leonardo DiCaprio, and he talks about some technologies that are being developed that can actually take carbon dioxide out of the atmosphere. So it's kind of interesting stuff. But the one that really impacted me was Kiss the Ground. It's a Netflix video that you can get right now. Woody Harrelson. It's about regenerative agriculture, and it talks about how to using different agricultural techniques, you can take CO2 out of the atmosphere, put it into the ground, and keep it there. So it's a really interesting documentary that I think everybody should look at. What else can you do? Become a climate activist. Make sure that everybody knows where you stand, and you'll be amazed at how many people think and feel the same way that you do. Join in the strikes and demonstrations. I joined the demonstration a year ago, September. I marched in, with the young people from. We went from the train station to City Hall, and there were quite a few San Jose State students there, and it was really great. And I kind of stayed in the background and watched all that energy and thought, wow, these folks are the ones that are going to make this happen. Join an organization like Sierra Club or 350.org or Climate Reality, Citizens Climate Lobby, Sunrise for younger people. It's good because they provide you with information. They provide you with a group that you can join and have activities and let it be known, where you stand. So doing this would be great. Or you can take climate reality training like I did. And I'll tell you, there were a ton of college students taking that training. In fact, I'm mentoring 11 of them right now from the last training that we had in July. And that's been really good. What else can college students do? Well, I mentioned 100% renewables. Talk about it with your friends, your relatives, your family. Make sure everybody knows where you stand. You can write letters to the editor. Campus newspaper would be a great place. Emailing your senators and representatives, and I do this a lot because some of the organizations I belong to send me these things and say, and it's real easy. You just click on a button and you write a letter. I've gotten responses back just in the last week from Dianne Feinstein and Kamala Harris, because I want them to, I wrote them about guaranteeing safe and free elections. And they wrote back and said, here's what we're doing. Now, obviously it's their staffers who are writing back, but it's nice to get a response back. And then they count you. They make, because you're part of their constituency, they count you in their statistics. And so the more of us that raise these questions, the more they think, oh, our constituents want us to do this, so we better do that. What else can college students do? Look for environmental resource courses. There are a lot of them on campus. So I would invite you to, if you haven't already done so, to look at what's available. And of course, join the Office of Sustainability, which is sponsoring this talk. They have Facebook, Instagram, Twitter. You can get online and follow them and find out what kinds of programs and events they're offering. So please do that. And educate yourself. I mean, you're all used to doing research. Educate yourself. Learn the truth about the science behind climate change. One last thing you can do is form a Climate Reality Campus Corps. The Climate Reality Project has a network of campus corps around the country. you can form your own SJSU Climate Reality Campus Corp Club. There are others locally like UC Berkeley, UC Davis. Santa Clara is now forming one, and you can too. Here's the contact, Emily Kiefer from Climate Reality. They will help you get it set up. And obviously on campus, you need a volunteer to be your faculty advisor. I would certainly volunteer. Maybe Ken would volunteer as well. But we would be happy, and he's nodding his head. So we'd be happy to help you guys out. If you're interested, email me or email Ken and let me know that you're interested in forming a club, and we'll be happy to work with you to make it happen. And lastly, electrifying. So all this says is we're moving from our gas powered appliances and trying to move them all to electric. It's cheaper, it's safer, it's better for the planet, and it gets the dangerous gas fumes out of where you live, which is extremely important. So lastly, the largest impact on climate change, what is it? Humans. So we are the single largest uncertainty regarding climate change, and what we do or don't do now will impact climate change forever. So what would the world look like if we were successful? So just sit back a half a second here. How about less smoggy days, or fewer devastating forest fires, or milder weather events, reduced immigration, more abundant and healthier food, improved health, improved and maintain our biodiversity, and a safe and healthy future for you all. So use your voice, use your vote, and use your choices to speak truth to power, like your world depends on it, because your world depends on it. Thank you all, and I'd like to open this up for questions. So,
Yes, if you anyone has questions, you can either unmute yourself and speak up, or type it in. We do have a question from Chelsea. Bill, do you see this question in the chat? That's maybe a good question for you to address if you saw the debate last night.
So what do you think about Biden's comment on last night's debate that he wanted to transition away from the oil industry? And how would that impact the job economy for folks who rely on that industry? Well, obviously, as I mentioned earlier, the largest growing jobs in the US are solar panel installers and wind turbine technicians. So we're creating more jobs than we're losing. The issue would have to be, yes, those people can lose their jobs, and can we retrain them to become technicians on wind turbines or solar panel installers? The fact of the matter is that in any massive transition like this, there's going to be some winners and some losers. And I would hope that people are starting to see that fossil fuel industry is not going to be in the long-term horizon, and that people are going to start to make those changes on their own and be moving away from that. So yes, it'll impact negatively some of the people who rely on that particular industry, but they're going to create a lot more job opportunities in the clean energy field.
I might also mention that a lot of the big projects that need to be done to tackle this problem need a lot of manpower, need a lot of workers, and there are a lot of technical jobs from well, they're just, I could go on and on about all the things that need to be done. And so if we really are serious about tackling this, there's no shortage of jobs to tackle it. Yeah.
Yep. Other questions? Fine, you must have questions. I'm not that good.
Maybe just a quick also follow up on what Biden said. Today, he maybe, I mean, he's worried about an election. And so he's saying that what he was trying to say was we should stop subsidizing the oil industry. And that, if you remember Bill's slide, saying that, we give trillions of dollars worldwide to fossil fuels, and if we don't want them, I mean, the sort of the very minimum we can do is at least stop subsidizing them and let the market decide. And I think from what you see, the trends and even the current prices, is the market would then quickly move on its own to renewable as soon as we stop subsidizing it. And at that point, the market forces will do what they will. The question is, are we going to do what Biden suggests and stop subsidizing the oil industry? There's another question for you, Bill, from Susanna.
Let me go back to the chat here. Where is it? Oh, wait a minute, 2 new messages. How do you feel about young people running for office to fight climate change? I think that would be great. I think there are too many gray hairs and no hairs like mine that are kind of running the world here. And we absolutely need, I mean, Susanna, this is your future. And, I'm not going to be around to see it, but you are, and your kids are. And we really need you guys to take that step forward. We and I will absolutely promise to back you up in whatever you decide to do, but you guys need to take the lead in this thing because, like I say, it is your future and people will listen to you. Okay. Alexandra says, do you think the academic world is doing enough in terms of outreach communication to make climate change a less complex topic for voters? No, I don't think, I think there's still a lot of confusion out there. And I think it can be simplified. I don't know whether you found my talk confusing or hopefully, made things a little bit more clear about what the issues are and why climate change, but it is an incredibly complex subject. I mean, there are so many factors that enter into climate change in terms of the emissions, in terms of how to stop emissions, how to take things out. And so it's not an easy or simple thing. And it really does require each and every one to do their own research to figure out what the best information is. Ken, you have a...
Well, I mean, not everyone is going to do their own research. And so we've got to have some level of communication. But as you saw from Bill's very clear talk, the essential part of the problem is not hard to explain. He did that in 3 minutes. And everybody, in a way, I think just about everybody can understand. And the essential part of the problems can also be quickly presented. All these problems, and people know about these problems. The solutions are hard. The solutions are hard. In fact, we have another question about kind of what's maybe the best and easiest solution. And if you talk to people who really think about this a lot, the sort of the number one thing on many people's list is simply to put a cost on the carbon that reflects what it is that all the harms we're experiencing. So if there was a tax on every kilogram of carbon that you emitted into the atmosphere, people would make better decisions. And at that point, it almost wouldn't matter whether people knew that this is going to help and this is not going to help. People see, well, this is cheaper and this is more expensive. I'm going to do the cheaper one. And so by putting a tax on carbon, you almost take all the complexity out of it for people, and they vote with their pocketbook as to what is going to help the planet the most. And there are many, many other things that need to be done as well, but that is right near the top of the list for sure.
And that's a topic that Citizens Climate Lobby is working very, very hard to get the carbon tax put through, because they feel like that would make a significant impact on carbon emissions. Sophie, talking about policies, number one on my list would be putting somebody in charge of the EPA who's actually interested in environmental protection. We just saw something in the paper today that the EPA is relaxing restrictions on the emission of methane out of landfills. And it's like, they're going to kill us and drive us right back into the dark ages, because methane is like 80 times more potent than carbon dioxide. And we do not want them releasing more methane. And yet the current guy in charge of EPA is doing, whatever the Trump administration tells him to do, and is really subverting what the EPA was originally intended to do, and all of the good policies that were implemented by the Obama administration. So I would think that that one thing, putting the right person back in charge of the EPA, could make probably the most significant difference. Maribel, yeah, having come from the corporate sector, yes, they do need to act. And I think I mentioned in one of my slides that 190 corporations, and a lot of them large, have vowed to become carbon free by 2050. So that was very, very good to see. And the way big corporations are going to move is basically when they see that it is cheaper for them to use non-fossil fuel products, they're going to go in that direction in a heartbeat, because the bottom line is what they look at. And having spent 28 years in that industry, I know. And probably the CFO of all those corporations is probably the toughest guy you're going to have to commit, guy or gal, is to convince that they need to move, because anything that they see that might negatively impact their bottom line it's just not going to happen. So that's why corporations are kind of acting a little bit slow. They want to see what the impact might be to make sure that that really is a good business decision. Again, you're not going to convince them to do it from an altruistic standpoint. It's going to have to be a bottom line positive thing. And as we've seen from the slides I showed you on clean energy, those costs have come way down. And once that becomes better known, I think people are doing it right now. In fact, I just read an article about a town in Kansas that was destroyed by a tornado, and they rebuilt. And that whole thing about rebuild better, that whole town was rebuilt, and they're totally relying on 100% clean energy to power their town. That's huge. I mean, it's a little tiny example of what can be done to take some action.
The other point of leverage on corporations is, of course, financial and insurance companies. And if the insurance companies are really awoke to what is happening to the world, because they're going to be on the financial hook for a lot of it. And if they stop insuring new oil rigs, and if banks stop loaning for this industry that they see is going to have to die for the planet to survive, whether the corporations want to change or not, if that's your main business is digging up oil, and no one is going to insure your stuff and no one is going to loan you money, but they will loan you money for carbon capture and shifting your industry to something that is going to help the planet, that obviously could be an enormous point of leverage on corporations beyond altruism. So.
And there's a lot of opportunities to let yourself be known. I've signed a number of petitions over the last couple of weeks, petitioning folks like Chase Bank and Wells Fargo. B of A is actually making some noise, but to get them to stop funding fossil fuels, like Ken is saying. And so we just really need to continue to let these folks know, hey, we don't want you doing this. Our pension plan, with San Jose State, they're moving in the right direction. They're huge. And we need to make organizations like that put a lot of money into the fossil fuel industry to start backing off. Why do you think, I quoted that, fossil fuel stock prices are down 40%. A lot of that has to do with the fact that a lot of financing or operations are not funding them. Okay, so it's going in the right direction. It's slow, I think, but it's moving. Any other questions? Okay, well, thank you for those questions. Thank you for hanging in there, all of you who are still online. I appreciate your being there. And I hope that you will take this away and will, do something with it. Hopefully maybe form a climate campus core, which I would be happy, Ken and I would be happy to work with you and see if we can't keep the ball moving in the climate change area. Thanks again to Debbie and the Office of Sustainability for sponsoring this talk. We really appreciate that. And hopefully we hope to do more things together in the future.
Thank you so much for doing this. And just for those who are still on, this presentation will be on our YouTube channel and we'll have subtitles. So thank you. Thank you, Bill. Thank you, Ken. This is awesome.
Okay. Thank you all. Bye-bye.